Without using technology, determine the following characteristics of the given functions: number of x-intercepts, value of the y-intercept, range, nature of turning point, end behavior, the slope for linear functions. We're given 4 different functions, and to determine the following characteristics, we're going to sketch them out. So I'm going to place going to be placing these planes here to help us visualize how these functions look. Okay. So A, f of x equals 4 will be a horizontal line like that, where that point, the y-coordinate of that point where it's crossing the y-axis is going to be 4. So in terms of the number of x-intercepts, well, this function never crosses the x-axis, so it has no x-intercepts. Value of the y-intercept, that's the y-coordinate where it's crossing the y-axis, is 4. Range, well, so range is the possible values for the dependent variable y. There's only one value because it's a horizontal line, so the range is going to be y equals to 4. Nature of the turning point, so there are no turning points, so no turning points. End behavior, so the end behavior describes the quadrant that the function is in or enters on the left hand side, and the quadrant where it exits on the right hand side. So this will be quadrant 1, this is quadrant 2, 3, and 4. So in terms of the end behavior, it starts out in quadrant 2, and then it ends up in quadrant 1 on the right hand side. This is a linear function because it's a straight line, and the slope for a horizontal line is 0. B. This time we have f of x equals negative 2x plus 6. This is a linear function. And if we take a look at the numerical coefficient in front of the variable is negative 2. That's going to be our slope. And the 6 here, plus 6, is going to be our y-intercept. So this means that this will be a straight line that's crossing the y-axis at 6. And it's going to be going down this way because the slope is negative. And so in terms of the number of x-intercepts, it has 1 x-intercept. Value of the y-intercept is 6. The range, so at the end of this function we can put these arrows, and so the range is going to be, if we use set notation, we can write it as, actually we don't need to use those curly brackets, we can just write it as y belongs to real numbers, which means y goes from negative infinity down here up to positive infinity up here. Nature of the turning point, there is no turning point. End behavior, so it starts out in quadrant 2 on the left hand side, and then it ends up in quadrant 4 on the right hand side. And then we have the slope. It's a linear function, so the slope here is going to be negative 2. C, f of x equals 2x squared plus 1. So we have an x squared term, which means it's a quadratic function. It's going to be a parabola that's going to open either up or down. The numerical coefficient in front of the x squared term will tell us which way it opens. If this numerical coefficient is positive, it means it'll open up. Okay, so it'll be opening up, something along that line. this plus 1 will be our y-intercept. So this is 1. So it's going to be opening like that and going through y equals 1. So we can see that it doesn't cross the x-axis, so there are no x-intercepts. The y-intercept is 1. The range, what are the possible values along the y-axis? Well, the smallest y value is 1, and then it goes up to positive infinity. So we would say, using set notation, so y such that y is greater or equal to 1, and as long as it is greater or equal to 1, y belongs to the real numbers. Nature of the turning point, it's a minimum. And the behavior on the left-hand side, it starts out in quadrant 2. On the right-hand side, it ends up in quadrant 1. And it is not a linear function, so we're not going to indicate any slope here. D, f of x equals negative x squared plus 9. Again, it's a quadratic function. Because the coefficient in front of the x squared term is negative 1, it means it's going to open down this time, something along this line. The y-intercept is going to be positive 9, so it's up here. It opens down this time. So it has two x-intercepts. Our y-intercept equals to 9. Our range, well, the largest possible y value is 9, and then it goes down to negative infinity. So y such that y is less than or equal to 9, and as long as it is that, y belongs to the real numbers. Nature of the turning point, it's a maximum. And the behavior on the left-hand side, it starts out in quadrant 3. And on the right-hand side, it ends up in quadrant 4. And there's no slope since it's not a linear function.